Chapter 1, Section 3, Properties of Numbers. The objective of this lesson is to learn to apply properties of numbers and find counterexamples. The first property of numbers is called the commutative property. An example that they have here is 6 plus 8 equals or is the same as 8 plus 6. So the order in addition does not matter. 12 times 8 is the same or equals 8 times 12. Again, the order does not matter, and in this case it's multiplication. However, the commutative property does not work for subtraction, nor does it work for division. So the commutative property works for addition and multiplication. An algebra example would be a plus b is the same as b plus a. A times b is the same as b times a. The second property is the associative property. 7 plus 9, that sum added to 1 is the same as 7 plus the sum of 9 plus 1. So in this addition example, the order in which you add these numbers does not matter. A multiplication example would be 4 times 2, taking that product and multiplying that times 5. That would be the same as, following the order of operations, 2 times 5 and multiplying it by 4. These are equivalent. The associative property works for addition and multiplication. However, it does not work for division and subtraction. The algebraic expressions over here are shown for the associative property as the sum of a plus b added to c is the same as a plus the sum of b and c. Notice the parentheses just changed locations. With the multiplication example, a times b times c is the same as, now remember our order of operations, this would be b times c, taking that product and multiplying it by a. Notice it's just the order that's different. The third property is the distributive property. In our first example, we have 6 multiplied by the sum of 9 plus 3. So that is the same as 6 times 9, that product added to 6 times 3. The red arrows indicate what can we do with the distributive property. We take 6 and multiply it by the first number, which is 9, and then 6 multiplied by 3, 6 multiplied by 9, 6 multiplied by 3. The operation sign is carried over, and that's addition. Over here is the example without numbers, and we're using variables. Another example would be 2 times the difference of 7 and 5. We could use the distributive property. 2 times 7 is 14. 2 times 5 is 10. And we're going to carry the operation sign. In this case, it's subtraction. We're going to carry that over in between. The identity property. An example would be 7 plus 0 takes it back to 7. 8 times 1 would be 8, back to its identity. So the algebraic example would be a plus 0 equals a, or a times 1 equals a. 0 property would be 9 times 0, as our example would bring it back to 0, or a times 0 would be 0. Use the given property to write an equivalent expression. The commutative property with 5 plus x. So if we look up at the table, the commutative property. 6 plus 8, if we apply the commutative property, we'd have 8 plus 6, where we are just changing the order. So in our first example, we want to change the order. 5 plus x, we use the commutative property to get x plus 5. 2, our example, 7 times y. That product is multiplied by 5. The associative property. Let's go back to our table. Let's look at the multiplication example. And from the left and the right, the only difference is where the parentheses are placed. So we need to change the parentheses down here. We are given the product of 7 and y, that is multiplied by 5. If we apply the associative property, we're going to have 7 times the product of y and 5. So the only difference is where the parentheses is located. In the last example on this page, we want to apply the distributive property to 5 times the sum of k and 8. Let's go back to our example. Let's use this first one. 6 times the sum of 9 and 3. Let's follow our arrows, so we could take 6 times 9 and then 6 times 3. Use the operation, in this case, of addition in between them. So down here, we would take 5 times k and then 5 times 8 and place addition between them. We're going to use the properties to determine whether the expressions are equivalent. In the first example, we have 7 times x times 6. The question is that the same as 13 times x? Sometimes it helps just to use a simple example. In this case, I'm going to use 1. I'm going to put 1 in for x. So now I would have 7 times 1 times 6. All I did was replace x with 1. 7 times 1 is 7, times 6 is 42. Now, we're going to use the number 1 for the letter x for this expression and see if these two are equivalent. So now I would have 13 times 1 on this side. Well, 13 times 1 obviously does not equal 42. So, no is the answer to does 7 times x times 6 equal 13x. On this side, in example 2, we have 5 times the difference of y and 11. Does that equal 5y minus 55? This would be using the distributive property from the previous slide. In that example, we followed the red arrows. 5 times y, there it is. 5 times 11 is 55. We bring over the operation sign of subtraction. So, is 5 times the difference of y and 11 equivalent to 5y minus 55? You darn tootin'.